A tunnel is dug along a chord of the earth at a perpendicular distance r/2 from the center's earth. The wall of the tunnel may be assumed to be frictionless. Find the force exerted by the wall on a particle of mass m when it is at a distance x from the center of the tunnel. Okay, this is my earth. Not big enough. A tunnel is dug along a chord. Okay, the distance of the chord from the center is r/2. This distance is of course r. A particle is somewhere at a distance x, and the distance x is from the center of the tunnel. The center of the tunnel, this distance is x. Now what I have to calculate is the force exerted by the wall on a particle. Now clearly that the force that is acting on the particle of mass small m will be towards the center, that is in this very direction. Alright, now what I have to calculate is the normal force. Now let's say make some construction. We join this part. In previous question I calculated the force acting on a particle of mass m that is at a distance x from the center. Fine. So this force, that is a force acting on a particle small m due to the complete earth, will be given by g into capital M, that is the mass of the earth, into mass of the particle, into r/2, I'm sorry, this distance, that is OA, into OA divided by r cube. Fine. So I can calculate the value of OA, that is not an issue. Fine. Let's say this angle is theta. The force acting between both of them is F, the magnitude of which I know. Then this force will be also equal to, this angle is theta again, so it will be F cos of theta, and the upper force will be F sin of theta. Now I have to calculate the force exerted by the wall. Now the force exerted by the wall will be a normal force, and this normal force will be in equal and opposite direction, and that will be in this direction. So the normal force will be equal to F cos of theta. So the value of F is G m into small m into OA divided by r cube into cos of theta. Right, now this is my triangle. The cos theta can be written as base divided by hypotenuse. So G into m small m into OA divided by r cube into cos of theta. Cos of theta is base upon hypotenuse. This is my base, that is r/2, and hypotenuse, that is again OA. So OA is cancelled over here, and 1r is cancelled from here. So I do have G into m into small m by 2r square. That is normal force exerted by the wall on the particle m, and that is my answer.